Hello everybody, welcome to the next chapter. Technically it's the same chapter, chapter 6. We're going to be in this chapter for the remainder of the year, really. Each of these sections is actually very long, so we broke it up into basically one chapter per section. So 6.3 is what we're going to be doing for the next 2 or 3 weeks. The chapter is called Parametric Equations. And essentially what it is introducing a third variable. Generally it's going to be t for time. So instead of using 2 variables with equations like we normally do, we're going to have 3 variables, and we're going to take a look at kind of what that looks like. Before we get there, for the sake of actually Thursday's class, we're going to take a look at different types of equations just as a refresher. I'm going to do every odd-numbered one here, and then you guys can fill in the blanks later on. Here's just an example of what I'm talking about. So the first one here, y equals 3x minus 6, that's a y equals mx plus b kind of problem. This is just a linear function. So you could write linear or line. You could write the shape that it makes if you want. Leave that one for you. X equals y squared plus 3. So just like y equals x squared plus 3 would be a parabola, this one is a parabola as well. So you could say parabola, parabolic. This one would be facing to the right, as it is y squared. Think about the conic sections chapter from last year. Y squared is facing to the right. Okay, down here, x squared over 4 plus y squared over 9 equals 1. So you might remember this from the conic sections chapter from last year as well. Equals 1, we have both variables squared, but they have different coefficients. This one is 1/4, that one's 1/9, divided by 4, divided by 9. So this is going to be an ellipse. An ellipse is the one where you added them and the coefficients were different. Moving on to this one, x equals 3. That is a vertical line. The x value is always 3. And that would happen in a vertical line. Finally, the last one, y equals ln of x. This is just a logarithmic function, as you can tell, because it has a logarithm in it. Okay, so that's the first one. You can fill in the blanks from there. Okay, so here's the introduction to what we're going to be doing this chapter. If you don't understand why we're doing it at first, that's actually okay. It will come together eventually, I promise, particularly once we start doing applications and you start to see why a third variable would even be necessary. By the end of this lesson, you might be thinking, why would we even do this if we have 2 variables? And the answer is because sometimes in the real world there are 3 variables in a situation, namely time is going to be the one we look at here. Okay, so here's how you do these types of problems. We're going to complete the table using integers from t equals -1 to t equals 5. Then we're going to sketch the ordered pairs in the xy axis and graph the function. So from -1 to 5, I'm just going to put in -1 to 5 in the chart over there. What we're going to do next is we're going to individually place each of these t values into the 2 equations above here. So for the x column, we're going to use the x equation, and for the y column, we're going to use the y. So when I plug -1 into the x column up here, 2 times -1 is -2, minus 4 is -6. I'm just going to go straight down here. So 0 would be -4, 1, 2 minus 4 is -2. And you can probably see the pattern here that emerges because it's a linear function. For the y values, it's another linear function, y equals -t plus 3. So if I plug in -1 here, that's +1. I get 4. -0, 0 plus 3 is 3. -1 plus 3 is 2, and we can see this one decreases by 1 each time. What ends up happening here is we plug the t values in, but the result is we get an ordered pair -6, 4. So this parametric equation has an ordered pair at -6, 4. The t value of -1 is kind of invisible on this graph as we plot it. So here's what it looks like. -6, 4, You have to go a little bit outside of the graph for this. So we have a point there. Negative 4, 3. Right there. Negative 2, 2. 0, 1. 2, 0. 4, negative 1. And then 6, negative 2. And when it's all said and done, connecting the dots, this makes a line. That line looks like it has a slope of negative 1/2, has a y-intercept of 1. So we also could have called this line y equals negative 1/2 x plus 1. And this is where you might be saying, well, why wouldn't we just graph y equals negative 1/2 x plus 1? Why do we have to have two different equations with a third variable? You're just going to have to go on faith that this will tie together eventually. It has to do with the idea that time is a third variable. Okay, that's that one. You guys can do this one. Let's move on to number 3, which involves trigonometry. Going forward for the rest of the year, including this chapter, especially in the polar chapter that's going to come later, it's going to be very important to kind of have the basic graph of sine and cosine like permanently implanted in your mind. So here's the graph of y equals sine of x. It starts in the middle, and one period would look like this, going from 0 to 2 pi. The maximum value is 1, the lowest value is negative 1. Y equals cosine of x. Similar looking graph, except it starts at a maximum, goes through, ends at a maximum, so at 2 pi, it's back at a max, at pi, it's at a minimum. So similar looking graphs, just different starting points. Okay, so here's how it applies to this problem. When I plug t equals 0 into this problem, I want to find 2 times sine of 0. Sine of 0 is 0, so 2 times 0 would also be 0. I'm just going to go just straight across the order pairs for this problem in case you decide you like that way of doing this better. So when I plug 0 into this function, I get 1. So cosine of 0 is 1 times 2 is 2. So we have an order pair at 0, 2, which would be right there. Let's see what happens when we plug in pi over 2. Pi over 2 is right here. That has a height of 1. 2 times 1 is 2. When I plug in pi over 2 to this one, that's that right there, that's 0. 2 times 0 is 0. Plugging in pi. Pi is right here. Sine of pi is 0. Cosine of pi is negative 1. 2 times negative 1 is negative 2. Now for all of these, you don't need to use these graphs. You could just go back to your unit circle where you have the order pairs 1, 0, 0, 1, and you could certainly use that as well. So for this first one, I could have said at 0 the sine value was 0 and the cosine value was 1, which became 2 when you multiply by 2, so you could get it that way as well. I'm just going to continue using the graphs going forward though. Okay, this should say 3 pi over 2 and 5 pi over 2. It will look that way by the time you get there tomorrow. So 3 pi over 2. If I take sine of 3 pi over 2, that's right here, that's going to be negative 1. Negative 1 times 2 is negative 2. 3 pi over 2 for cosine right here, that's where it crosses, so it's 0. You might be noticing a pattern here. At 2 pi, we are back to the start again. So the sine value is 0, the cosine value is 1, times 2 is 2. And the pattern starts to repeat itself, because at 5 pi over 2, we are back here again. So the same thing as pi over 2, we get 2 comma 0. 3 pi would be the same as pi, so it's 0 comma negative 2. So we get this kind of repeating pattern. Okay, so we plotted 0 comma 2. Now 2 comma 0 is right there. 0, negative 2 right here, and negative 2, 0 here. So we have done this one, this one, this one, and this one. 0, 2, we are back here again. 2, 0 there, 0, negative 2 there. So you can kind of see we're just going to go around in this circle over and over and over again. So the first plotted point was this one. So it goes around like this. And back up there, making a complete circle. Just for the sake of showing understanding, I think it's good to show me that you know what you're doing just by showing the arrow there, so I know that you know that at t equals 0 it starts here, and the direction it generally travels is that way. And this equation would have just been x squared plus y squared equals 4, it being a circle. And one of the things we're going to be doing in this chapter is talking about how this and this somehow do create the same graph. Okay, you guys try number 4, and I'll put up the answer key. Good luck, and let me know if you have any questions. Welcome to the next chapter.